I'm Patrick.
I'm Manny.
And Linda's on the camera and reporting in from my garage doing our physics project on ferrofluids and magnetic fields. But before we get to show you all the cool stuff, all the fun stuff, we have to do all the boring stuff first. So let's check out this PowerPoint quickly about ferrofluids. Okay, so let me just give you a quick rundown of ferrofluid and its relation to magnetic fields before we get to show you all the cool experimentations. So, what is a ferrofluid? Ferrofluid is any fluid that can become strongly magnetized if exposed to a strong enough magnetic field. It is a colloidal suspension, meaning that it has evenly distributed particles, and it is a mixture as well, so it's kind of like milk. These particles that are evenly suspended are magnetic solids, which are composed of about roughly 5% of the whole fluid itself, and in this case it'll be filaments of iron. 10% of this fluid is surfactants, which cover the microfilaments, and then 85% is carrier fluids, usually oil, and in this case vegetable oil. Okay, 3 important notes about ferrofluids. Each ferrofluid has its own specific Curie temperature, which is basically when the fluid gets too hot and it loses its magnetic properties. The only other time it loses its properties is if it just becomes too old and stagnates. And the Curie temperature for ferrofluid containing iron is 770 degrees Celsius. So obviously you're not going to see it exposed to this kind of temperatures on a regular basis. Second off, ferrofluid will form these spikes and valleys when exposed to a strong enough magnetic field. These causes the fluid to exceed its normal properties of stabilization, and you get to see some pretty cool effects. And lastly, the resistance of the fluid directly relates to the magnetic field it's exposed to. It seems pretty obvious, but the bigger magnet you have, the stronger magnet you have, you're going to see greater effects, and vice versa. Okay, so real-life applications. The biggest real-life application of ferrofluid are in electronic devices like computers, and specifically in the hard drive and the hard disks. It's used to coat the spinning shaft in a hard disk, and then it uses magnets to obviously stabilize the fluid, and then it will protect the shaft or the disc when it spins, and it'll keep debris away from it, just so the computer will run properly. There's also a great amount of other applications, less significant, but in the fields of mechanical engineering, aerospace, analytical instrumentation, optics, medicine, and even art. So we'll get to show you a few of those later. Alright, so now it's time to go back to the experiments. Alright, just to reiterate what we displayed in the PowerPoint, Linda's going to discuss the more important properties of ferrofluid, which you can see here. But before that, just note that ferrofluid is relatively easy to make. What you'll only need to make it is MICR toner and vegetable oil, which can be bought at your office supply store and your local grocer, respectively. So if you want to try this at home, yeah, you can do it. It's pretty fun. Alright, so go ahead, Linda.
Ferrofluid is a colloidal suspension consisting of about 5% iron nanoparticles, 10% surfactants surrounding the particles, and the rest is oil.
The vegetable oil would have been that oil in this case. But for the sake of time and not insulting your intelligence, we're not going to show us making it.
Okay, so basically ferrofluid, it tries to mimic the magnetic field. So it can't really fully do it because of the surface tension of the liquid.
Okay, so now we're going to show what happens when the ferrofluid is exposed to a magnetic field. With just one magnet to start out.
One magnet?
Right. One magnet, gray magnet.
Yep.
Okay.
You guys ready?
Yeah, I think we're ready. Are you ready, Linda?
Alright, you ready?
Right.
Check
Alright,
this
prepare to be
out.
amazed, guys.
No way.
See that? Wow.
This
Is that a bump, dude?
I think it's a lump.
Dude,
Yeah.
I think it's a lump too. Here, let me get. Oh yeah, dude.
You can like
that's
you can like move it like a magnet. Like
Wow,
a
are you
magnet.
kidding me?
Interesting.
Yeah.
Is this real life?
This is so cool.
All right, let's try this. Get a little daring here and put 2 magnets on. Yeah,
rambunctious,
this
you know.
might get a little bit crazy.
Let's get 2 magnets.
What is that 2?
2 magnets right
Let me see.
here.
All right,
2 magnets.
2 magnets. Okay.
All right. This is gonna be crazy. Check
All right,
this out.
ready, Linda?
Right.
Hold on to your horses.
All right. Look at this, guys. No
Oh
way.
my. Wow.
A bigger lump.
A bigger lump.
This is crazy.
Dude, this is real life. All right. Well, that about wraps it up for our demonstration on Ferrofluid.
Yep. Pretty cool, right?
Yeah, pretty cool. So, thank you for watching our demonstration.
And I hope it didn't pee your pants. Excitement.
This is what you'll get. This is what you'll get when you mess with us.
Okay. Well, obviously that was a joke.
Yeah, pretty bad joke.
Lame.
Stupid. Last time we used this magnet, this kind of unnameable material.
Really weak.
Really weak. Not really important what it's made out of. So we don't need that anymore. Now we have these stronger magnets.
Real
don't
deal.
Yeah, real deal. Don't be deceived by their size. These are made out of neodymium, which is a rare earth metal, and it can be it's actually really abundant in the Earth's crust, so it's not really rare. Just the name is given on the periodic table of elements.
These are the strongest magnets, permanent magnets known to man.
Yeah, there's obviously some electric magnets that are stronger, but these ones are the strongest that you can purchase, basically, in regular life. So now we're just going to do the same experiment as before with about 5 of these neodymium magnets, and it's going to be...
the Ferrofluid right here.
Yeah, it's going to be a little bit more exciting. So we're going to watch the nanoparticles of iron in this fluid react to this magnetic field. Alright, so you can see it start to form some spikes.
Look at that. Spikes getting bigger.
Spikes getting bigger, balling up. See that, Linda, catching
Yeah.
that?
So basically those spikes are the magnetic field the ferrofluid is trying to mimic.
But it's failing to do so because of the surface tension. You can notice that on the sides of the little ball that's being created here it's actually round, it's not spiky, and that's because the magnetic field is a lot weaker on that side.
It's weaker on the sides, yeah.
So you can basically move this around. It's going to stick to the bottom of the thing without having to hold it, obviously. And then you can just bring it up on the sides. It's pretty cool looking and makes a great display. But we're just going to try this again, and we're going to...
This time we're going to add a few more magnets.
Yeah, just a few.
Make it more dramatic.
About 40 more, so this should obviously increase the magnetic field and make a better display of its properties. Alright,
look at that.
that's pretty cool. So you can see the spikes forming, and the field is obviously stronger on the sides. You see there's not as much roundness, and the spikes are more defined, more pointy, a little bit thinner as well.
More numerous because the magnetic field is obviously stronger.
You can just see me now moving it away from the field, so you get some pretty big spikes there. And we're just gonna bring it to the side here.
Yeah, you can move it around like anywhere. Yeah, pretty much.
Pretty cool stuff.
Yep.
Seems to like to stick to the container though. Alright, so now we're gonna just do a few displays of its properties, core displays. So here we have a separate container of the ferrofluid, and in it is a nail.
One nail.
Just one nail, or screw, whatever you want to call it. It's coated in the fluid, and we're just going to see what happens.
When it's magnetized.
Yeah, it's
by
going to
the
be an
magnets.
extension of the magnetic field into the metal here. You can see it start to bunch up. Oh, this is not easy. You can kind of see the fluid. There you go. Hold on. You can kind of see the fluid reacting to it. Not that cool. But now what we're going to try is putting a magnet in the fluid itself.
Covering it.
Covering it. So let's just take one of these weak magnets now. Weak ones first. Actually, you can put it in this one right here.
Got the fluid.
Got the fluid here, and let's drop it magnet in. All right,
Cover it up.
it's covering the magnet as much as possible. You remember this is the weaker magnet, so it's gonna be weaker.
Yeah.
And you can slide it. It's pretty cool. You can slide it around all over the place.
Yeah, the ferrofluid gives it a more smoother sliding property.
You know, obviously with the oil.
Yeah.
Pretty sick. So now we're gonna try dipping
Stronger magnets.
a few neodymium magnets in here.
You want to do it in that one since it's pure?
Yeah, we'll do it right in this one,
We'll do it in this one.
the pure form of it. All right.
Just drop
Well,
it in there.
This is the end of them. Okay, just gonna drop it in there. Oh wow.
Oh, look at
That's
that.
that's a pretty cool effect right there, actually.
It just forms a ball
Yeah, it forms a ball, obviously.
around it.
You can see here a better display of the effects of the poles. If you can see it well enough.
You can see the spikes are on the sides because those are obviously where the magnetic fields are stronger.
And where the poles are, and you can see in the middle it is forming the ball, which we saw earlier in the experiment, where this is where the magnetic fields are weaker.
Yeah.
And you can just basically
slide it around.
slide it around, yeah, on the sides a little bit, maybe. Nah. All right, so.
Yeah.
Yep. Yeah, so let's just
add a few more.
now I'm just gonna play around with it a little bit. These things are strong. All right, this could be a problem here. This might get a little bit messy. As you can tell, my hands are pretty disgusting at this point. Should have worn gloves, but for my arm, oh my god, that was a horrible idea.
It's okay.
It's all right. It's all right.
It's pretty cool.
All right, it's all in the name of science. So
All for science. As you can see,
Yeah.
there's more spikes.
More spikes.
More spikes, more magnetic field.
it's got a magnetic field, and it's getting a more oblong shape due to the increase in magnets.
Yeah.
So, all right.
That's that.
That's that. So,
See? Patrick's a little messy.
I'm a little messy. So, thank you for watching our experiment on Ferrofluid.
Hope you enjoyed it.
I enjoyed it, obviously. It's all over me. We have to get a magnet to get it off. But, thank you and have a nice day.